All right, so in one of the most common ones, something called a nickel or NiCad batteries, nickel cadmium batteries. And this is kind of what these look like. These came in a variety of shapes and sizes. So you could get NiCad, D batteries or NiCad AAA batteries as well. And this is kind of what they look like on the inside. That this was actually a whole bunch of the same series of electrodes and separators and cathodes and all that. And the reaction occurs at the cathode this is again while it is in the discharging mode, that the nickel is being reduced from nickel plus 4 in this nickel oxide to nickel plus 2 in this nickel hydroxide compound. And at the anode, the cadmium is being oxidized from cadmium 0 to cadmium 2 in this cadmium hydroxide. So the overall reaction is the nickel oxide reacts with water and the cadmium to form nickel hydroxide and cadmium hydroxide. And again, these things were constructed in such a way with these separators that the current could flow, and you get about 1.5 volts from this battery as well. And if you supplied more than 1.5 volts in the opposite direction, you could drive this in the reverse direction, regenerate the nickel oxide and the cadmium, and battery's good to go, for typically a few more uses until some of these materials in the inside would start to break down, and the current would then not flow in the charging direction very well. And so these also had some other issues, namely that the nickel and cadmium cadmium in particular is kind of toxic. And these also resulted in batteries that were fairly heavy. Enter lithium-ion batteries. So these are the current battery of choice for mobile rechargeable because they're actually fairly light. They provide a pretty high energy density so that you can get a lot of power storage or a lot of energy storage in them with not a lot of weight. The reaction that goes on in them is actually pretty complicated. And this is the discharging reaction of a lithium-ion battery. And so that is that the lithium plus 1 ions and are intercalated with not are reacting with cobalt 4 oxide, take an electron and form this compound thing, which is neutral. And so the lithium ion takes in an electron, becomes a lithium atom, and combines with the cobalt oxide. At the anode side, the lithium is actually complexed with a bunch of carbon. Basically, it's a graphite ring of 6 carbons. And it can be oxidized and it becomes just a carbon, kicks out the lithium ion and the electron. So the overall reaction is the cobalt oxide reacting with the lithium carbon complex, forming the lithium cobalt oxide complex and the uncomplexed carbon. So the graphite. And so electrons can go freely from one to the other, and these things can be made in a way that you can, send current, you can force current in one direction to charge it, and then have the current flow spontaneously in the other direction, which is what the discharging reaction is. So there's actually quite a bit of chemistry going on in your lithium-ion battery. All right, so the next kind of battery that you see is something called a fuel cell. What makes a fuel cell special is that the fuel is constantly being supplied, so it's not really storage energy, but it's a way of converting chemical energy directly to electricity. And one of the first examples of this, which was an incredibly expensive one, is this thing right here, which is a device that facilitates this reaction. So at the anode, you have hydrogen gas reacting with hydroxides to form water and 4 electrons. At the cathode, you've got oxygen gas taking up 4 electrons to form water and 4 hydroxides. So the oxygen is being reduced from 0 to -2 in this case, and the anode is being oxidized. The hydrogen is being oxidized from 0 to +1 in this case. And what's the overall reaction if you put these things together? Well, the electrons cancel, the hydroxides cancel, and it is simply hydrogen and oxygen forming water. Now, usually, when you do this directly, you get an explosion. This is a very energetic reaction. And energy is given off in the form of heat, some sound, not so much electricity. But in this case, this is a way. This fuel cell is a way of if you can keep, the anode and the cathode's chambers separate. This is combustion, reaction with oxygen at a distance. The hydrogen and the oxygen never actually come into contact, but the electrons are transferred from one to the other, and you end up with water by virtue of this electrochemical cell. But this is a way of actually having combustion where none of the energy given off is given off in the form of heat. And this is incredible. And this is a very good thing because most engineers count the creation of heat as the most useless thing ever. It's the most useless form of energy. Now, depending on how cold it is when you're listening to this video, you might think otherwise, but trust me, heat is fairly useless and very easy to make when you need it. And so remember that Q is not a state function, so the energy difference between the hydrogen and the oxygen and the water is what it is, and it's large. But it doesn't necessarily have to be manifested as heat. And these fuel cells across the board represent the most efficient use of the potential energy of chemical reactants. And so typically, and this reaction would, provide a voltage, and all you would need to do is just continually supply the hydrogen and oxygen into this cell, and it gives you electricity and gives you water. Now, that picture from the previous slide, this was put into spacecraft, where the production of electricity and water was actually, both of them are kind of desired products. The heat might not necessarily be such a product. So you've got the electricity, which you can do anything you want with, and you got the water, which you need to drink. Now, you can also do other types of combustion in a fuel cell. Namely, you can combust methane. Now, this one's a little tricky because it requires molten or liquid potassium carbonate and lithium carbonate as the electrolyte, hence the term molten carbonate fuel cell. And you can also, if you build one of these, you can also combust other hydrocarbons like propane or butane. But again, this would also represent the most efficient way to convert the potential energy stored in the methane and the oxygen to use all of it is converted into useful energy, namely electrochemical energy.